Welcome to The Explainer. So today we're diving into an absolute marvel of human engineering. It's been roughly 3 years since NASA's James Webb Space Telescope was launched on its mission, and honestly, in that incredibly short amount of time, it has fundamentally rewritten our entire understanding of the cosmos. Just think about it. We built the ultimate time machine, a machine that can peer through deep time all the way back to the Big Bang, just to show us exactly how planets, stars, and galaxies are formed, and what happens when they violently die. Today, we're going to look at the absolute best of what this telescope has discovered so far.
All right, here is our cosmic itinerary. We're going to take a literal zoom out today. We'll start with the ultimate time machine, then check out surprises in our solar system, move on to strange new exoplanets, witness the lives of stars, and finally explore deep space and ancient galaxies. Let's get right into it. Now, to really grasp what we're looking at, you kind of have to understand a core difference in how Webb actually sees the universe compared to past telescopes, like Hubble. Hubble primarily uses visible and ultraviolet light, which tends to bounce right off cosmic dust. But Webb was explicitly designed to see in the infrared spectrum. This means it can detect the faint glow of warm dust and, way more importantly, peer straight through thick clouds of interstellar gas to see the hidden structures inside. It's literally like putting on X-ray glasses for the universe. Okay, part 1. Surprises in our solar system. Discoveries close to home. You know, even the planets we think we know inside and out are hiding some massive secrets. Take Jupiter, for instance. Webb actually found a completely unknown high-speed jet stream racing at 515 kilometers per hour right above the equator. And on Jupiter's moon Europa, it detected carbon dioxide on the icy surface. That's an essential building block for life, likely bubbling up from a hidden subsurface ocean. It also gave us our clearest view of Neptune's rings in over 30 years and spotted the incredibly delicate Zeta ring around Uranus. But my personal favorite? Centaur 29P. Webb caught this giant mass of rock and ice, blasting out jets of carbon dioxide and carbon monoxide. It's a phenomenon researchers lovingly refer to as giant asteroid farts. You can't make this stuff up. To put things into perspective, 9,600 kilometers. That's the actual size of a massive water vapor plume Webb detected erupting from Saturn's moon Enceladus, right from its southern pole. That single plume of water is a staggering 20 times larger than the moon itself. It's direct evidence of how the hidden ocean inside Enceladus is literally feeding water to Saturn's entire system, rings included. Moving on to part 2, strange new exoplanets, bizarre worlds beyond our sun. So our catalog of bizarre alien worlds is just expanding so rapidly right now. For example, there's a planet called WASP 107b that is literally puffy like a marshmallow because its interior is incredibly hot and its massive core is severely lacking methane. Then we have TRAPPIST 1b. It's a completely barren rock baking at 232 degrees Celsius on its day side. Oh, and there's a planet with a 300-degree temperature disparity between its sunrise and sunset sides. And surprisingly, the sunset side is actually the hottest. We've also measured a planet with equatorial winds blasting at an unfathomable 8,000 kilometers per hour, just to redistribute heat. And Webb even found a freezing cold gas giant sitting at just 2 degrees Celsius. That proves this telescope can spot exceptionally cold, dim objects, not just brightly burning stars. But hey, it's not all extreme hostile environments out there. If you've ever wondered, are we alone? Well, Webb is actively hunting down the exact ingredients we need for life, right where they need to be. For the first time ever, it detected water vapor in the Goldilocks zone of a distant solar system. It was found within 100 million miles of the host star. And why does that matter? Because that is the precise region where rocky, Earth-like planets typically form. Okay, part 3. The lives of stars, cosmic nurseries, and violent deaths. It's absolutely wild to think about the complex chemistry happening out there. Deep within these icy molecular clouds, way before a star has even fully ignited, Webb's instruments are detecting complex organic molecules. They've even identified alcohol trapped in the icy regions of these cosmic nurseries. It suggests that the foundational ingredients for life-supporting environments are already present at the very genesis of star and planet formation. And Webb isn't just watching stars being born, it's watching their intricate, decades-long dances. It captured this incredible binary star system surrounded by 17 perfect, concentric dust rings. So what's actually happening here is that every 8 years, these two stars approach each other in their elliptical orbits. Their stellar winds violently collide, which compresses the surrounding gas into a ring of dust. Over time, these shells expand outward, creating a pattern that looks exactly like the rings of a cosmic tree trunk. Every single ring marks a specific period in the star's orbital history. Now, when these massive stars finally reach the end of the line, They essentially become the ultimate recycling centers of the universe. And remember, we're talking about the exact same elements that make up your own body right now. Webb peered into the Crab Nebula and Cassiopeia A, which is the youngest known supernova in our galaxy, by the way. Through infrared, it revealed these expanding shells of material packed with bright pink and orange clumps of sulfur, oxygen, argon, and neon. Plus, by observing two other exceptionally dusty supernovas, Webb proved for sure that these exploding stars are directly responsible for producing and scattering the cosmic dust that eventually forms new planets and early galaxies. Which brings us to part 4, deep space and ancient galaxies, the edge of the observable universe. So to see the very first galaxies, Webb has to rely on a totally mind-bending trick of physics called gravitational lensing. Basically, because these ancient galaxies are so impossibly far away, their light is extremely faint. But if a massive object, like a giant galaxy cluster, sits between us and that ancient galaxy, its immense gravity physically bends and magnifies the light from behind it. The universe is effectively creating its own cosmic magnifying glass for Webb to look through. But there's a catch with this cosmic magnifying glass. While it lets us see incredibly far, it also creates absolute visual madness. It severely distorts the light. I mean, Webb has captured a distant galaxy that was perfectly warped into the shape of a giant glowing question mark. And in areas like El Gordo and Pandora's cluster, we see these massive stretched gravitational arcs of background light swooping across the view. It's basically a surreal funhouse mirror effect, but on a galactic scale. And thanks to that exact gravitational lensing trick, Webb was able to spot Arundel. This is literally the most distant star ever detected by humanity. It sits an unfathomable 28 billion light-years away from Earth. It's a massive star, over twice as hot as our sun and 1,000,000 times brighter, and the light we are seeing from it right now was actually emitted during the universe's first billion years of existence. This kind of visual madness is completely reshaping how we understand galactic evolution. We're seeing things like the elegant Sombrero Galaxy, where Webb's infrared pierced right through the visible light to reveal a smooth inner disk. We've seen the Penguin and the Egg. That's two interacting galaxies where gravitational forces have stretched one into the shape of a penguin guarding an egg. We've seen the Cartwheel Galaxy, which has this rare ring shape formed from a high-speed galactic collision. But honestly, perhaps the most surprising discovery is that when researchers looked at the earliest, most ancient galaxies, they didn't look like elegant spirals at all. They looked flat and elongated, closely resembling cosmic surfboards, or as the researchers officially called them, giant pool noodles. Way out here at the edge of space, Webb isn't just looking at isolated structures. It's seeing the foundational architecture of the universe itself taking shape. It discovered a massive space web made up of 10 distinct galaxies, completely linked together. This massive structure dates back to just 830 million years after the Big Bang. It gives us this unparalleled insight into exactly how gravity began to string matter together in the early cosmos. But you have to remember, the early universe was a chaotic place. Webb peered into a dwarf galaxy from about 1.5 billion years after the Big Bang and found an exceptionally hungry supermassive black hole. This black hole was consuming its surrounding matter at a rate over 40 times faster than what astronomers thought was theoretically possible. And honestly, this hungry black hole solves one of the biggest early mysteries from the Webb telescope. At first, the telescope spotted galaxies from just 500 million years after the Big Bang that looked way, way too large and bright for their age. It made no sense. They shouldn't have had time to grow that massive. But the new data suggests a brilliant solution. The galaxies aren't actually impossibly massive, they just have incredibly hungry black holes at their centers. The intense radiation from those black holes rapidly consuming matter makes the galaxies appear deceptively massive and bright. It was a total cosmic optical illusion, completely solved by this incredible machine. It's honestly just staggering to look at the sheer volume of these discoveries. In roughly 3 years, the James Webb Space Telescope has peeled back the dust of the universe. It's uncovered jet streams on Jupiter, water near alien worlds, stars making alcohol, the cosmic pool noodles of the early universe, and black holes eating 40 times faster than they should. It leaves us with a truly thrilling question to ponder. If it has decoded this many universe-shattering secrets in its first 3 years, what is it going to find tomorrow? Keep looking up, and we'll see you on the next explainer.